Welcome to the Level 2 video on solving systems of equations. Today we're going to be looking at a particular system with 3 equations and 3 unknowns, and that system is 7x plus 5y minus 3z is equal to 16, and we'll call this equation 1, 3x minus 5y plus 2z is equal to minus 8, and we'll call that equation 2, and 5x plus 3y minus 7z is equal to 0, and that can be equation 3. We're going to be solving this system in 2 different ways, but we're going to start off solving it using substitution. Okay, so first thing we're going to do is solve equation 1 for x. So we look at equation 1, rearrange for x, and we have that x is 3z minus 5y plus 16, and that's all divided by 7. Okay, and let's take this. So let's substitute x into equation 2 and also equation 3. And then in equation 2 and equation 3 we'll be removing x. So let's go ahead and do this, and let's start with equation 2. So equation 2 becomes 3 times 3z minus 5y plus 16 all over 7 minus 5y plus 2z equals minus 8. If we multiply this out and then multiply the whole thing by 7, we're going to have a 9z plus 15y plus 48 minus 35y plus 14z is equal to minus 56. Now simplifying this one more time, we have minus 50y plus 23z is equal to negative 104. And let's label that equation 4. Now we look at equation 3, becomes 5 times 3z minus 5y plus 16 all over 7 plus 3y minus 7z is equal to 0. Now multiplying this out and again timesing by 7, we've got 15z minus 25y plus 80 plus 21y minus 49z is equal to 0. And finally, simplifying this again, we've got 34z minus 34z minus 4y is equal to minus 80. And we can label this equation 5. So let's go ahead and solve equation 5 for y. So y is going to be 80 minus 34z over 4. And dividing top and bottom by 2, we've got 40 minus 17z over 2. So if we substitute this y into equation 4, to get minus 50 times 40 minus 17z all over 2 plus 23z equals minus 104. Multiplying this out, we've got minus 1000 plus 425 z plus 23z equals minus 104. And then finally 448z is equal to minus 896, which implies that z is 2. So if we have z, then we can substitute this into our expression for y, which was 40 minus 17z over 2, so that y is 40 minus 17 times 2 all over 2, which is 20 minus 17, which is 3. And then finally, if we've got z and y, we can substitute z and y into our expression for x, which is 3z minus 5y plus 16 all over 7, and we get that x is 3 times 2 minus 5 times 3 plus 16 all over 7, which is actually 1. And this gives us our x, y and z, but of course these are simultaneous equations, so we can check our answers just like we do in the 2 by 2 case. 7 times 1 plus 5 times 3 minus 3 times 2 is meant to be 16, and it is, so that's correct. 3 times 1 minus 5 times 3 plus 2 times 2 is meant to be minus 8, and it is, so that's correct. And finally 5 times 1 plus 3 times 3 minus 7 times 2 is meant to be 0, and it is, so our solutions are all correct. So let's look at solving the system using the second method, which is elimination. And let's quickly remind ourselves of the system. So here is the system, again with the same labeling we had before. So let's solve this using elimination, and let's first of all eliminate y first. So if we take equation 1, add it on to equation 2, and we get 10x minus z is 8, and let's call that equation 4. Then if we take 3 lots of equation 2, add it to 5 lots of equation 3, we get 34x minus 29z equals minus 24. And this gives us two expressions in x and z, which we can solve simultaneously. If we times equation 4 by minus 29 and add it to equation 5, we will have minus 290x plus 29z plus 34x minus 29z is minus 256. Simplifying this a bit further gives minus 256x equals minus 256, which implies that x is 1. Substituting this into equation 4 gives us that 10 times 1 minus 8 equals z, which is 2. And equation 1 now that we have z and x gives us that y equals 16 plus 3 times 2 minus 7 times 1 all over 5 equals 15 over 3, 15 over 5, 15 over 5, which equals 3. Thanks very much for listening.